Welcome to Math Tutorials. In this video, we are solving every question of exercise 7.3 of Chapter 7, Integrals, from the NCERT Mathematics textbook for Class 12, Part 2. Exercise 7.3 integrates with trigonometric identities. 24 questions using half-angle reductions, product-to-sum formulas, odd power peeling, and clever factorizations, with 2 multiple choice at the end. Here is the list, grouped. Question 1. Sine squared of a linear angle. The half-angle identity removes the square. Sine squared is 1 minus cosine of the doubled angle, over 2. Apply the identity to the angle 2x plus 5. Integrate half x minus the sine over 8. Question 2. A product of sine and cosine of different angles. The product-to-sum formula splits it. 2 sine cosine is sine of the sum plus sine of the difference. Integrate each sine. Question 3. 3 cosines multiplied, 2 rounds of product-to-sum. Pair the first 2, then distribute the third. First pair, cosine 2x cosine 4x, is half of cosine 6x plus cosine 2x. Multiply by cosine 6x. A cosine squared and another product, each reduced by its identity. Integrate the 4 flat terms. Question 4. A cubed sine, peel one factor and convert the square. Then substitute the cosine. Write sine cubed as 1 minus cosine squared, times sine. U is cosine of 2x plus 1 with du carrying minus 2 sine. Integrate the polynomial in U. Question 5. Odd powers on both. Peel a cosine for the substitution. U is sine x. Write cosine cubed as cosine times 1 minus sine squared. With u as sine x, the integral is u cubed minus u to the 5th. Integrate the 2 powers. Question 6. 3 sines, product-to-sum twice over. Pair sine x with sine 2x first. The first pair gives half of cosine x minus cosine 3x. Multiply by sine 3x and expand both products into sums. Integrate the 3 sines. Question 7. 2 sines of different angles. Product of sines is half the difference of cosines. Apply the identity. Half of cosine 4x minus cosine 12x. Integrate the cosines. Question 8. The half-angle tangent squared in disguise. Both numerator and denominator are half-angle squares. 1 minus cosine is 2 sine squared half x. 1 plus cosine is 2 cosine squared half x. Tangent squared, then secant squared minus 1. Integrate 2 tangent half x minus x. Question 9. Cosine over 1 plus cosine. Add and subtract 1 upstairs. The remainder is a half-angle secant squared. Split off 1. The leftover is minus 1 over 1 plus cosine, which is minus half secant squared of half x. Integrate. Question 10. The 4th power of sine, 2 rounds of half-angle. Square the sine squared identity. Sine to the 4th expands through cosine 2x and cosine 4x. Integrate term by term. Question 11. The 4th power of cosine 2x. The same double reduction with plus signs. Expand through cosine 4x and cosine 8x. Integrate. Question 12. Sine squared over 1 plus cosine. Factor the numerator as a difference of squares. Sine squared is 1 minus cosine squared. The factor 1 plus cosine cancels. Integrate the 2 terms. Question 13. A symmetric difference over a difference. Convert both double angles to squares and factor. Cosine 2x is 2 cosine squared minus 1. so the numerator is twice the difference of squares, which factors over the denominator. Integrate, alpha is a constant. Question 14. The denominator is a perfect square in disguise. 1 plus sine 2x is sine plus cosine squared. With u as sine plus cosine, the numerator is exactly du, and the denominator is u squared. Minus 1 over u. Question 15. An odd power of tangent with one secant. Save a secant-tangent pair for du. Write tangent cubed secant as secant squared minus 1 times secant tangent. U is secant 2x. Integrate the quadratic in u. Question 16. The fourth power of tangent. Strip off tangent squared as secant squared minus 1 twice. Tangent to the fourth is tangent squared secant squared minus secant squared plus 1. The first term integrates by u equals tangent. The rest are standard. Question 17. Split the sum over the product of squares. Each piece becomes a secant or cosecant family term. The split gives sine over cosine squared plus cosine over sine squared. Secant tangent plus cosecant cotangent. Both are standard derivatives. Read backwards. Question 18. The numerator simplifies dramatically. Cosine 2x already contains minus 2 sine squared. Cosine 2x is 1 minus 2 sine squared, so the numerator collapses to 1. The integrand is secant squared. Integrate. Question 19. Multiply through to expose secants over tangent. Then substitute tangent, dividing by cosine to the fourth inside. The integrand is secant to the fourth over tangent. With u as tangent, secant squared dx is du, and secant squared is 1 plus u squared. Split and integrate, log plus half square. Question 20. Cosine 2x factors as a difference of squares. One factor cancels the squared denominator. Cosine 2x is cosine minus sine times cosine plus sine. So the integrand is the ratio whose numerator is the derivative of the denominator base. The log form. Question 21. Inverse sine of cosine, a constant minus x in disguise. Cosine x is sine of pi over 2 minus x. So the integrand is simply pi over 2 minus x on the principal branch. Integrate the linear function. Question 22. Two shifted cosines below, the sign of the shift difference unlocks it. Multiply and divide by sine of a minus b. Sine of a minus b expands as sine of the difference of the two shifted angles, splitting the fraction into two tangents. Each tangent integrates to a log of cosine, combine into one log ratio. Question 23, multiple choice. Split the difference over the product. Two familiar squares appear. The split gives secant squared minus cosecant squared, which integrates to tangent plus cotangent. Option A. Question 24, the last one, multiple choice. The numerator is the derivative of xe to the x, so the integral is secant squared of u. With u as xe to the x, du is e to the x times 1 plus x. The integral becomes secant squared u, giving tangent. Option B. That completes all 24 questions of exercise 7.3. In the next video, we will take up exercise 7.4 on integrals of some particular functions. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.